Hi, it's time for the math. Easy solution. Here to discuss further into integrals and volumes and look at example 2 of this video series. Basically, this example states: find the volume of the solid obtained by rotating about the x-axis the region under the curve y equals x power of 1 over 2, or basically y equals square root of x, from 0 to 1, and illustrate the definition of volume by sketching a typical approximating cylinder. Yeah, so if we were to draw this this function right here, y equals square root of x, looks something like this, and this is from 0 to 1. So basically, first thing we could do is draw this, just show the illustration of the volume definition by sketching this. So if we were to go, let's say, at this x point, so if we were rotating this around this x-axis, we would basically, we'll put this right here. So this height right here is square root of x. That's the height, because that's just a y value right here. And so that's just a y, and the y equals square root of x, so that's just square root of x height. So if we were to rotate it about the axis, we get something like this, and it looks something like yeah, just volume like this. And then at this point right here, it looks something like this at this general x value right here. And if we were to draw a cylinder, roughly would look something like, yeah, like this. I'll just switch the color. So let's just draw it like that, and we, as you can see, we have a cylinder like this. If we were to shade in this whole cylinder, looks like this with a with a width of delta x. So this is how the cylinder would look like, but with the definition of volume, we basically make this infinitely small and make these infinite cylinders. Yeah, and we would basically take the integral of this volume from 0 up to 1 right here, and this area right here at a general cross section is equal to a of x is equal to, well, this is just a circle, so because we're just rotating it around as a circle, so this is a circle, and the volume, the area is going to be pi r squared, and in this case r is just equal to square root of x. So pi square root of x squared, that is square roots and squares cancel, so we have pi times x. That's the volume. So and that's the area. So our volume now is just equal to, from 0 to 1 of this area times dx, pi x dx, and this equals to, well, take the integral, this equals 2 pi x squared over 2 is integral of x. Put this from 0 to 1. So now we plug these in, so we have pi 1 squared over 2, that's just going to be, well, pi over 2, subtract this by, we'll plug in 0, zeros just cancel, so we're just left with pi over 2 as our answer. Yeah, and now basically we got this answer, but the question we can always ask ourselves is, did we get a reasonable answer? And in this case, we can actually just quickly double check by considering the function y equals 1 instead. So we'll get a function that looks like, yeah, it looks something like this. This is y, this is x. Just draw a horizontal line, and this is at 1. This is just y equals to 1. So if we were to rotate around this whole thing like that, and now we have a constant area, so it looks something like this, and the area across the entire thing is just, it's going to be area is equal to pi r squared. In this case, our radius is always 1, so it just equals to pi. So if we were to take the volume of this one, volume is equal to, from 0 to 1 of pi dx, that's the area is just pi, this equals to, well, pi x from 0 to 1, that's just equals to pi. So as you can see, if we were to consider this entire volume, we'll get a volume of pi, but if we were to use, basically, this kind of looks like half of it, we get pi over 2, so roughly this is double. And I'll just write that down. That's in our example. The volume is computed as half of this full cylinder's volume, which seems about right, and it's a good double check of our work. Anyways, that's all for today. Hopefully you'll learn from this video, and like always, yeah, you can download these exact notes in the link below. And anyways, thanks for watching, and stay tuned for another math easy solution.